we will see what is computer architecture and why do we study computer architecture. Today, computer has become an integral part of our life. In all kinds of applications, in all our daily life, computer plays an important role, starting from email to bank applications. Computers of different types for different applications are available in different forms, handheld to large computer forms. As far as the cost is concerned, computer technology has made incredible progress in the past 60 years, which any other technology has not made. The performance of a computer which was costing 1 million rupees in 1985 is now available for rupees about 25,000 rupees as a personal computer, with more performance than what it was and with more memory and disk storage. The improvement in performance has taken place over a period of time. For the first 25 years, technology and better architecture had a steady growth of 25% per year. Afterwards, technology played a major role, and in late 1970s, microprocessor integrated circuit technology, because of that, there was 35% performance per year. Then came architectural improvements, most of them on software and instruction level parallel processing, and that made a very good progress. From 1980 onwards, architecture moving away from assembly language, introduction of standard operating systems, RISC processor and ILP, for 16 years they had about 52% per year. And in about 2002, there was a little dip. This progress of 52% was slightly lowered to that of 20% per year. And then people thought of using multi-core, thread-level parallel programming and data-level parallel programming. And because of that, in 2005, multiprocessor architecture, TLP and DLP is taking over. The performance, if you could see, initially we had a high growth, then we had about 52% growth continuously. Then around 2002 there was a slow dip, and once again because of DLP and TLP it is slowly increasing further. The trends in computer usage, the increased amount of memory is used now. Previously the total memory that was available in a computer system was very much less, and we people have been using only that small memory. Now every program uses lot of memory, and that requires improvements in DRAM technology and also reduction in cost. And the replacement of assembly level language by high level language, it has become easier to construct compilers and to write many programs, and compiler now is the primary interface between the system and the user. And as far as the technology is concerned, integrated circuit logic has improved, and transistor density increases 50% per year, and device speed also increases every year. But definitely the wiring technology is slow, cycle time is also slow. The semiconductor DRAM increases 60% a year, and latency decreases every year. Magnetic disk technology also has improved about 50% a year. These things contribute to lower cost and improvement in performance. But you would see here, the process performance improvement is taking this curve, whereas the DRAM technology is taking continuously or uniformly this. There is a small gap, or I would say this is a larger gap in the performance, and this gap in performance has to be has to be bridged And this bridge is being taken up by the other kinds of architectural procedures like pipeline execution, instruction level parallel processing, thread level parallel processing, data level parallel processing. All these technologies, all these architectural procedures have come in to bridge the gap, and also the memory hierarchy plays a major role in the performance between the CPU and DRAM. We will leave this. The growth has taken in two ways. More complex components that followed Moore's law, that is components complexity doubled in 18 months. And at the same time, each component becomes more complex. And all these were possible because of technological developments as well as architectural changes. As a computer science engineer or IT professional, one should know about what are technological changes and architectural changes that have brought in this much of performance. Let us see what is computer architecture. As a definition, we would say the structure and behavior of a computer system as visualized by a computer programmer as working at the assembly or machine language level. Or, I would say this, a conceptual model of a computer at a particular level of abstraction, I would say this particular level is those system programmers who would work with the system. We can redefine this as a structure and behavior of all hardware and software components as visualized by a system programmer. That is what we would call that as a computer architecture. One would decide, in order to design a new computer system, he has to visualize what he wants, the structure as well as the behavior of the hardware and also the software components. And once he views this or visualizes that, according to that he has to design a system. This would include instruction set, data formats, addressing modes, general design of CPU, memory, I/O systems, and organization. Organization includes logical aspects of implementation, but the implementation, we would say, logical and physical design techniques used to realize the architecture. What are the objectives of an architect? In the sense, computer architect. He has to determine the essential functionalities required for a new machine, maximize the performance within the constraints such as cost, space, power, etc. More or less similar to a building architecture. Why do we go to a building architect? It is not enough that we leave everything to our own imagination, but we give only the requirement to the architect and also the constraints, the total amount that is available, the area that is available, and the requirements as how many rooms, what would be the size, whether it is bath attached, and these informations only are given, but it is for the architect to decide how it is to be connected and in what way, where to have a door or where to have a bathroom, where to have a kitchen, what way it is to be organized. All these things will be the function of an architect. In a similar way, computer users have to give their requirements, functional requirements for a new machine, and it is for the computer architect to design the new machine which would definitely meet all the requirements, at the same time maximize the performance within the constraints given as the cost, also the space and power. So once again we should remember that computers are different for different purposes and for different functionalities. We cannot have a desktop system to be taken on a satellite or in a satellite. So there cost is not a constraint, but space and weight is a constraint. Power is also a constraint. So one should remember that there are different systems for different functional requirements. with best performance. A lorry, truck, bus or a car does the same function of transporting, but what is the difference? The difference is whether we want to have a speed or whether we want to have a total load or whether we want to have a comfort. All these things are the differences, and therefore the automobile designer will take into account of the functionalities and the design. Similarly, computer architect also has to take into account of the functional requirements, but at the same time he would also see, he would maximize the performance within the cost provided. These tasks would include instruction set design, as I said earlier, functional organization, logical design and implementation, and this implementation would include IC design, packaging, power, cooling, etc. This requires knowledge on wide range of technologies, that would be compilers, OS, logic design and packaging. Even as a user of a system, one should know what is the system what his system should be capable of doing, and functionalities it should be able to do to perform, it should be able to perform to meet his requirement. Type of the system is purely based on functional requirement. Selection of a system based on the requirements and performance is an important aspect. We would have, I just mentioned this, we should not think when we say it is a computer system, all computer systems are the same. Architecture makes large difference, hardware also makes large difference. I just classify into 4 categories, but there are many systems. The classifications could be personal mobile devices, desktop computers, servers, embedded computers. Each has its own function, each has its own performance, energy requirement, its own applications are totally different. That we should remember, and if you put the computers into different categories, servers are once again different types of servers, web servers, database servers, like that. Depending on the requirement, the servers will differ, and at the same time architecture will also be different. And so when we go in for a new computer system, we have to think of essential functional requirements, what are all the components involved, constraints such as cost, weight, power, size, etc. And then how to organize all those things, and those things have to be specified. As a hardware designer, researchers should know how to design a processor, cache, storage, graphics, interconnections and so on. As a system designer, a system designer should know how to build a computer system using the best components available. As a software engineer should know how to get the best performance from the hardware. One should also know how to test the performance of a system and choose the one for his requirement. System performance also dependent on the exploitation of resources of the system. The software engineer should be in a position to write the program exploiting the resources to achieve the best performance.